Hello students, welcome to one more session of your 200 expected questions in world of chemistry. This is your Vani ma'am. Alright students, so today I'm back again with three more important questions. Little bit gap, but not a problem. Whichever video I upload, every question would be very important for your board exam. Right students? So today let us see what are we going to learn. We are going to do one physical chemistry numerical, one more physical chemistry numerical, one more inorganic chemistry, and we will see how we can answer it. Organic chemistry also, if time permits, I'll include in this. Right, students, let us start off. Welcome to the session. We are on day 12 of your series. In these day 12 or 12 days, a lot of questions are done. So I request you to all to share this video. Please, students, share this video so that it will go to students who can't afford this, afford the education also. Thank you so much, students. Let us read the question. We'll see the question. We'll read the question slowly. We will write how to write the steps in the exam, how to write the steps in the exam, and also check what to write the units also. Let us see the question. Very big question today. Let's see. Cesium chloride has BCC arrangement. So body centered arrangement is what they have given us a clue, and the unit cell edge length is so much, right? 400 picometers is the unit cell edge length. Calculate the inter-ionic distance in cesium chloride. So basically in NCERT, in solid state chapter, we very well know there are different questions like calculation of number of atoms, calculation of density, calculation of radius ratio, correctness students. But here, this particular question is something which is different. That's nothing but calculation of inter-ionic distance. This is also easy. We will check how to do it. Basically, this is the cesium chloride crystal, students. Okay, just as you have seen, the chloride ions are here with the negative charge, and the cesium ion is in the center with the positive charge. Okay, the cesium ion is here. This is the BCC centered lattice because why? Because this BCC, you have an atom at the center, in the body centered. Correct, students? So in this particular question, first point number 1 is chloride ions are present on the all the faces, means that particular the top one at the corners of the cube, and cesium ion is present at the body center. Let us write the first one and understand. First point number 1, what to note, students? Cl minus ions, okay, are where are they present? Yes, present at the corner. At the corner. Point number 1. Next, where are the cesium ions present, students? Cesium is represented by plus, and cesium ion is present at the center of the cube. At the center of the cube. Correct, students? It is present at the center of the cube. Okay. Now, what should I find out? First of all, when I see this particular cube, right, I need to calculate the inter-ionic distance between these two ions. So let us start off from the edge length. You all know what is the edge length, no, students? See, these are the edges. B to C is an edge. C to D is an edge. Okay, these are the edge lengths. Now, I'm going to draw one diagonal. From B to D, one diagonal is there because body diagonal. So it's easy for me to use the Pythagoras theorem and do it. So one particular body diagonal. Now let us start off with the first one. First point is if edge length of the cell, okay, if the edge length of the cell is A, okay, edge length of the cell is A, then what would be the distance, students? Then the distance BD, because I have joined this diagonal, isn't it? So if I take the edge length as A and this is the diagonal, so what would be, according to the Pythagoras theorem, if I take this is A, then I can write what is BD, isn't it? So calculate BD. BD is equal to square root of A square plus A square, which is equal to root 2A. Correct, no students? Yes, done. So I got the first one. Now next, step 2. BD is root 2a, I have written here. Now let us calculate for AD. Let us calculate for AD. This part I'm going to calculate for AD. Let us take the next one. Let's start calculating. And distance, second point, distance between AD. What is distance between AD, students? Let's come back. What is distance between AD? This is already root 2a. When I take this whole right angle triangle, I got the basis root 2a. So this is root 2a and this is a. So let us write that distance between AD is root of, put the a, root 2a whole square plus a square. How much this is AD now? AD is equal to root 3a. Both are over. Now edge length, how much did they give me, students? A value they have already given me. They said 400 picometer. Let us write that. But edge length is given as 400 picometer. This is what is given. Now substitute that value here. Substitute that value here. I'm going to write the same thing because space is less. I'll put one line here and write. Substitute that value. What is that value? AD is equal to root 3 into 400 picometer. So root 3 is how much, students? It is 1.732. So AD value 1.73 into 400. If I solve this, I get an answer of 692. But we very well know the distance AD is equal to 2 into interionic distance. Correct, my students? Because here when I see the cube, this AD is constituting, or if I see the distance, it is twice the interionic distance between this ion and this ion. It is twice of it. So I'll write the formula here. AD is equal to 2 into interionic distance. 2 into interionic distance. So now using this formula, what am I going to do? Check here. Half into AD, or half into AD value is 692. So it's nothing but 346 picometer. That's the answer. Easy. Question seems to be difficult, but easy answer, students. Okay. Let us see the next question and understand. This is from your electrochemistry. What do they give? Calculate the standard cell potentials of galvanic cell in which the following reactions take place. They have given the cell reactions here. And one more task is calculate the delta G naught value and equilibrium constant of the reaction. So there is one reaction given to me between chromium and cadmium, iron and silver. Products are also given and it is a balanced equation. It is a stoichiometric equation. So I have to calculate two things. Standard cell potential E naught also I have to calculate, and delta G naught also I have to calculate. Now for calculating such things, what should I require, students? I require electrode potential values. In the exam it will be given. So just I'll write for your for using it in the numerical. E naught for Cr plus 3 by Cr is, this is from the electrochemical series. Yes, students? Right. The electrode potential value. And for your cadmium by Sun is minus 0.40. For Fe by 3, this will be given for you to you in the exam. Not a problem. These are all volts. Okay, right? And the last one, silver. Okay, silver, the Ag plus by Ag value is 0.80. That's. Now let's start with the first one. The first one is there, no? This particular one. Let us write the cell notation. So the first one, Cr by Cr plus 3, salt bridge, Cd plus 2 by Cd. How did I write this? I have taken this equation, Cr getting converted to Cr plus 3. CD plus 2 getting converted to or reduced to CD plus CD. So I have written that with the salt bridge notation. So we know one formula now students, E naught cell is equal to E cathode minus E anode. Correct, no? Right. Cathode. So in this particular case, what is the cathode students? So basically check here. From if I have to see this value, if I have to see this value, chromium to Cr plus 2 to Cr plus 3, loss of electrons. 3 electrons are lost. Loss of electrons is oxidation. From Cd plus 2 to Cd, gain of electrons, so reduction. So this is your cathode. Reduction always happens at cathode. Oxidation always happens at anode. So the cathode value is cadmium value. What is the cathode value? Cadmium value, which is equal to minus 0.40 minus of anode value. How much students? It is minus of 0.74. So when I solve this, I get an answer of plus 0.34 volts. Simple as that. Simple as that. This is over. Now I have to calculate delta G naught. So if I have to write delta G naught, the formula is direct in V. How many electrons are transacted, students, here? Ma'am, how do I know this? Basically, N is the number of electrons transacted. Write the reaction 2Cr plus 2Cr. Okay. I'm copying the same reaction which is there, which this one. This reaction I'm copying there. So 2Cr plus 3Cd plus 2 giving me 2Cr plus 3 plus 3Cd. Now check, students, check. From 3 2s are 6. 3 2s are 6. So how many electrons got transacted? 6 electrons. Correct, no, students? 1 cadmium plus 2, 3 cadmium, 6 electrons. So here N is nothing but 6 minus 6. 1 Faraday is 96,500 into electrode potential. How much I got? Just now 0.34 volts. So when I solve this, I get an answer of almost units mole inverse, or you can further write it into kilojoules as 196 point, shift the dot, kilojoules per mole. So this is for one more is there, no, students? They've asked me to find equilibrium constant also. Equilibrium constant also. Further, log K value also I have to find. Log K. What is this? Equal to E naught cell into NF by 2.303 RT. Substitute that value in this. Substitute the value in this. E naught cell, how much? 0.34. That is right, the value. E naught cell is 0.34. N value is 6 electrons I got. Correct. So 2.303 RT, that I can write it as 2.303 into RT. If I calculate, I can write it as 0.059. Correct. No? Substitute the values now. Log K is equal to, according to the formula which I've used, this formula, earlier formula, I'm substituting the values in this formula. Okay. Now NF. Now one more thing, students. This F also is here, no? F also, 1 Faraday is also there, because this F is there, no? That F also divided by 2.303 RT is the total thing. So I am writing that value here. Correct, my students? So basically one thing, students, 1 by 0.509, I think you understood how we have got. So F by this value. So here, once we solve, I'm going to get an answer around this one. Okay, I have to find anti-log now. I did one video also how to find log and anti-log. you check that video which is kept in the playlist. This is the answer. This is for the first one. Understood, students? Now for the second one. Let me check how many pages I have. 2 pages. Okay, I have 2 pages here. I'll use it for both. For the second equation to solve, again, write down the cell notation, salt bridge, done. Now, step 1 to calculate, E naught cell. Write the formula again, E cathode minus E anode. How much did they give me, students? How much was the value when I saw the first one for this? For silver, Ag plus 2 to Ag, 0.80. Next is chromium, Ag and iron. So basically, one second, let me check. Iron and silver are given. So iron value and silver value, right, students? So iron value, how much was it? This is 0.77, students. I'm sorry, this is 0.77. This is 0.77. I'm sorry, this is 0.77. Okay, right. So I'm going to take both iron value and I'm going to take silver value and substitute there. So how much is it, students? E cell is equal to 80 cathode value, that is silver value. This is gain of electrons, cathode. This is loss of electrons, anode. Correct, no? So 0.80 minus 0.77. How much will I get? 0.03. That's E naught cell. Now, step 2 is what, students? Step 2, I have to do what? I have to calculate delta G naught. Write the equation. This is the equation which they have given. Correct, no? So here I have to calculate, or I have to calculate N. So check from Fe plus 2 to Fe plus 3, 1 electron. Ag plus 2 to Ag, 1 electron. N is equal to 1. Delta G naught is equal to, so N is how much? 1. Correct? 1. How much is the electrode potential I got? Minus 0.3. Faraday is how much? 96,500. I'll be getting an answer of this. If I convert into kilojoules, shift the decimal. Okay, I got this. Okay, got it, students? Right? Now, I need to find log K because they've asked me to find at equilibrium constant also, no? Again, I'm writing the formula. Right? So if I substitute the values, E naught cell value and N value and everything, because E naught cell value, I have got it earlier as 0.03. So here, substitute that value and take it here. Okay, 0.03 into 96,500 and everything. Fine, students. So when you apply this value, right? So how much do you get? Check carefully. Sorry, I don't have place, so I'm writing it here. Not a problem. This is 0.03 no value. This is also 0.3. Okay. Right, students. Sorry. I should write here 3. When I substitute, I get an answer of 0.508. Remember. Further, I have to calculate what, students? K value. Anti-log 0.5. K is equal to, that's. So here 3 steps are there. First, calculating E naught, then calculating delta G naught, then calculating log K value. So Right, students? Log K value also. This is what are all the 3 steps which we have put. Right. Let us see the next question of inorganic chemistry. That's nothing but account for the following. So easy question, students. Let's see. This is from group 18. This is from group 18. They've given a question. Account for the following means reason the following. The boiling point of noble gases increases with increase in atom or atomic number. Basically, this is not atoms number. This is atomic number. The boiling point of noble gases increase in atomic number. Students, simple, understand. For the first one to reason or account for the following, understand carefully. First, as molecular mass increases, what happens, students? Size of the noble gas increases. Noble gas atom increases. Noble gas atom increases. Now, what will happen to the van der Waals forces of attraction? Extent of van der Waals forces. The force of attraction between them, yeah, also increases. No, also increases because more and more molecules are added. So van der Waals forces of attraction also increases among molecules. Correct. Now, size in molecular mass is increasing, size is increasing. Size is increasing, forces of attraction are increasing. Now, if the forces of attraction are increasing, what will happen, students? What will happen? Automatically, boiling point. So, boiling point also increases. Correct? It also increases. Point number 1, start from there and give the reason. So, see here, the boiling point of noble gases increases with increasing atomic number. So, I have written all the keywords required. Next, students. Neon is generally used in warning signal illumination. Why? So, nothing. Why we are using neon gas for giving as a warning signal? Nothing, students. What is the speciality of neon gas, students? Neon lights, okay, neon lights, if you're using it, there you can see them even when there's mist fog during your winter season. Early in the mornings you have this mist and fog, no? So neon light can be seen even in mist and fog, and even in long distance. Hence they are used. Okay, that's the next question. So next, for protecting electrical instruments, neon is generally used in safety devices. So they may give you questions from based on the applications also, right? Why we are using in the safety instruments is what they are asking you. So there's one property of neon, students, right? It can, neon, when you're, it can carry high current, means when you are holding neon gas in that, no? High current and high pressure, when you're trying to apply, you can use neon gases under those conditions also. So in safety devices, what happens, right? When you're protecting certain electrical instruments, you apply high pressure and high current. So in that also it will not ionize. That's the reason. So I'm writing the last one once again. It is because of the property. Why I'm using in the safety devices? Because property of neon. What is that? Neon, it can be used under high current and high pressure. Okay, so hence it is used in safety devices. That's instruments, right, students? For that. So These are the three questions. I think you once again will go back and check. So first question, I did this for your solid state chapter. Steps I have explained. After that, we did one question from electrochemistry. All the three steps. Step 1, I have written, taken it. Step 2, I have explained this. Step 3, we have taken this part. Okay. Second, again, step 1 for calculating for iron and silver. Step 2, little bit clean explained. And step 3. This covers all the concepts of electrochemistry. Then comes your inorganic chemistry. So all the three reasoning questions, how to write in the exam also, I have explained. So thank you so much, students, for watching. I hope you are all watching the practical video. I'll meet you again with one more video very soon. Thank you so much. Please share. Thank you.